Let's do this question from the CAT 2017 slot 1 paper. Simple happiness index of a country is computed on the basis of parameters: social support, which is given as S, freedom of life choices, given as F, and corruption perception, which is given as C. Each of these three parameters is measured on a scale of 0 to 8, and it says integers only. A country is then categorized based on the total score obtained by summing the scores of all the three parameters as shown in the table. So let's look at that table. It shows 0 to 4 is very unhappy, 5 to 7 is unhappy, 9 to 13 is neutral, 14 to 19 is happy, and 20 to 24 is very happy. And if you see here, it says following diagram depicts a frequency distribution. So it's talking about the frequency distribution of the scores of S, F, and C of 10 countries. And the countries are given here. So what does this mean, this graph exactly? If you look at this orange graph here now, which is F, you'll see that two of them has got a score of 1 for F, and there is one of them who has got a score of 1 for C, right? And here we also know that, S, nobody gave a score of 1. So for none of the countries, there's a score of 1. So it's 0. So this is basically frequency distribution. Again, if you look at this one, it says 3 countries got a score of 3 in S. And then 2 countries got a score of 3 in F. And 4 countries got a score of 3 in C, right? So that's what this graph is talking about. It's a frequency distribution. The frequency means how many times is it showing up, okay? Now, this question actually looks at a little bit of statistics, but it's more of a numbers question. We have done this kind of questions before. This is basically looking at constraints in terms of sum, most of the questions in this. So let's get into this and try to understand how do you look at it. So firstly, I'm going to make this graph simpler by just writing this here as a table. Now, if you see S for Social Security, none of the countries got a score of 1. None of the countries got a score of 2. 3 countries got a score of 3. 3 countries got a score of 4. 2 countries got a score of 5. One of them got 6 and one of them got 7. So if you add all this, 3 plus 3, 6, 7, 8, 9, 10, this total is coming to 10. Similarly, all the total have to be 10 because there are 10 countries. So 2 countries got, for freedom of choices, score as 1. 1 country got freedom of choices score as 2. 2 countries got it as 3. 1 country got it as 4. 3 countries got it as 5. And one of them got it as 7. If you see this table, none of them got a score of 8 for any parameter, correct? So because it's given as 0. Now let's go ahead and look at the constraints which are given to you. So you have Amanda and Kala jointly have the lowest score 7 with identical scores in all 3 parameters. So this is going to make things a bit more easier because you know that 7 can be made as 1, 2, and 4, or you can have 1, 1, and 5, or 2, 2, and 3, or a 3, 3, and 1. These are the 4 possibilities. Now, if you look at this, I have made this table here saying that Amanda and Kala can only have 4, 1, 2 or 3, 1, 3 as a possibility. Why is that so? Because if you look at, if I put Amanda as 1, 1, and 5, and here again Kala as 1, 1, and 5, then what would actually happen is, for Social Security, 1 would have at least come 2 times, but it's showing it as 0. So obviously this is not possible, isn't it? Similarly, if you look at 2, 2, and 3, 2, 2, and 3, 2, 2, and 3. So 3 has to be there 2 times. That's possible for C, right? 2 has to be there 2 times for F. Not possible because it's only coming 1 time. And then you have 2 has to be there 2 times for S, which is also not there because S, there is Social Security, it is 0 times. So obviously these 2 cases are not possible. So which means we can go with this and this case. So let's check this out also. So 4 has to come at least 2 times. Yes, it's coming 3 times for Social Security. And then you have freedom of choices, you have 1 coming at least 2 times. Yes, that's possible. Corruption index, you have 2 coming in at least 2 times. Yeah, that's also possible. Let's check the other one. 3 has to come at least 2 times for Social Security. Yes, quite possible. 1 has to come at least 2 times for freedom of choices. Yes, that's possible. We already mentioned that here because even in this case, it's the same. And corruption has to come, has to have 3 at least coming 2 times. And that's quite possible because it's coming 4 times here. So these 2 are the only possible cases now, right? Now let's go ahead and look at the other constraints which are given. So it says Zuma has a total of 17. Now, how can I make a total of 17? Either I can have a 7, 7 and a 3, because let's remember that 8 is not there, and 7 plus 7, 14. If you take 6 there, it will go to 20. If you take 5 there, it will go to 19. 4, it will go to 18. So 3 is the next possibility. Similarly, if you look at 665 is possible, 557 is possible, 764 are possible. But you also have a mention here saying all 3 countries which categorized as happy have the highest score exactly in 1 parameter. Now see, if it's categorized as happy, it should get a score above 14, right? Not above 14, greater than or equal to 14. So if you now look at this, it also says all 3 countries which categorize as happy have the highest score in exactly 1 parameter. That means if you look at S as a parameter, then one of them has to have the highest score. F as a parameter, one of them has to have the highest score. And C as a parameter, then the third one has to have the highest score. Now see, there are 2 7s here. One in S and one in F. And then we have 2 6s also here. One here and one here. But we definitely know that highest for Social Security is going to be 7. Highest for freedom of choices is going to be 7. Highest for corruption is going to be 6. So these are the 3 numbers that we are going to look at. So I'm going to erase this one because this is of no use to us. So these are the 3 numbers that we are going to look at, because the countries which had been categorized as happy, one of them should have Social Security at 7. The other one should have freedom of choices at 7. And the third one should have corruption at 6. And that should be, for all of them, that should be the highest possible, right? So let's now get into and look at this. So here, if you see, there are 2 7s and 2 6s. That means what? That means for 2 parameters, we'll have highest as 7 and one of the parameters highest as 6. And we know that's going to be corruption, right? And also one of the countries will have a rating of 7 and 6 in 2 of its parameters. Okay, so let's now go ahead and make the cases for this. Now see, out of all these 4 possibilities now, this particular case is definitely not possible. Why definitely not possible? Because a 7 can come either here or here. That means definitely a 5 has to come for corruption. And if 5 comes for corruption, that is not possible, because for corruption index, there is no 5 rating given for any country. So this is not possible. Then you have a 7, 7 and 3. The case of a 7, 7, 3 is definitely not possible. Why? Because if you take 7, 7, 3, one of the country which is there will have for Social Security as well as freedom of choices, both of them the highest, which is not possible, because each country among those 3 should have only exactly 1 parameter. So these 2 are gone. So we are left with 665 and 764. So let's see how we can use this now. So these are the 4 possibilities now. I can put for Zuma 7 at Social Security, 4 at freedom of choices, 6 at corruption. Or we can have 7 here, in which case 6 can come here, 4 can come here, or 6 can come here and 4 can come here. Or we can put it as 665, in which case 6 can come only in these 2 places. That means 5 will be in between. So these are the 4 cases. Let's see whether these are possible itself. So I'm going to now put the biggest numbers there. So 7 here, which means the other 7 is going to come here, and next 6 is going to come here. Or I can put the 7 here, in which case the other 7 is going to come here and 6 is going to be here. Or I can have Zuma at 6 and the other 2 at 7 in these 2 places. These are the three different possibilities. Now, if you look at the very first case, this one, you will see that for Zuma, 7, 4, 6 is not a possibility at all. Why? Because if you're going to put 6 here, then this corruption index 6 is already taken away by Zuma, so this case would not be possible. So that we know is not possible. So this case itself does not exist. So let's move on to the next one. You have 4, 7, and 6. Is that possible? So 4, 7, and 6, that means 7 comes in the middle, and 4 could come only on this side. Why? Because if the 6 comes on this side, then the 6 will get this 6 and this 6 is not possible together, because you can only have 1 6 there. Same case as before. So this case is also not possible. So the only possibility are these two, 6, 7, 4 and 6, 5, 6. Now, let's look at the question. Amada score in F, that's very clear, because whichever case you take, it has to be 1 only, because even so, going back to the previous one, so this or this, it's going to be 1. Next one, pretty much simple now. Next one. What is Zuma score in S? So what is Zuma score in S? So let's look at this. In both these cases, Zuma score in S is going to be 6. A 6 here, a 6 here, right? So in both these cases, it's going to be 6 only. So Zuma score is going to be 6. Now let's look at the third one. We have Benga and Delma, 2 countries categorized as happy, are tied with the same score. What is the maximum score they can have? Now, we know that these are the only 2 cases possible for Zuma, 6, 7, 4 and 6, 5, 6. Now, definitely another 17 is not possible for both of them together, because you will need more 6s and more 7s, which is not there because you are already exhausted with your 6s and 7 in these cases itself, right? So 17 is ruled out. What about 16? In case of 16, if you see, there are 765 is there, 664 is there, 655 is there. These are all the cases which are possible. If you take 765, you need more 7s and 6s, not possible. If you take 664, same case, because you need more 6s and more 7s, not possible. If you take 655, still you need 1 6 extra. That is also not possible. So 16 is also ruled out from here. Next case is 15. So 15 is possible if I'm not going to take this case, and if I'm not going to take this case where we need multiple 6s and 7s, the other cases, it is quite possible. So I made this case here. So if X takes 7, 5 and 3, that will tally up to 15. And then you have 4, 5 and 6, which will also tally up to 16. And you can have 2 5s here. Yeah, that's possible. 2 5s, right? You can have a 4 here. Yeah, that's possible here. Yes. And you can have a 3 here. That's also possible. So that tallies. And then if you have 5, 7, 3, that also tallies, because 5, there are 2 of them here. So that's possible. A 3 is possible, and 4, 4 is also possible, because there can be 1 4 here and another 4 here. So both these cases are possible. So the answer for this is going to be 15. So the last question in this, if Benga scores 16 and Delma scores 15, then what is the maximum number of countries with a score of 13? Now 16 is possible only in this way, 655, because we already said 765 and 664 is not possible. So we come to know that 16 is only possible in this particular case, where 16 can only come here, because in this case now it's not possible at all. So which means 655, it comes here, 753 is only possibility, because 762 is not possible, and 744 is now not possible because 2 4s cannot come here, isn't it? So this is the only possibility. Now let's look at how we can figure how many 13s are there. Now if you see in this particular graph, 7s are all exhausted, 6 are all exhausted, only 1 5 is left for social security, 1 is left for freedom of choices, a 4 in corruption is also gone, finished. So that's not there. So how can I make a 13? Only in one way, 5 plus 5 plus 3. That means the answer for this question is going to be 1. That's about this question. So it was a bit of statistics understanding, but a lot of numbers. So that's what this question is all about. So these kind of questions are quite popular. So try to do more questions on numbers to get a hang of, how you will look at constraints and make combinations of sum.